I think it would be helpful to understand just the mechanics of exactly how a well is drilled. And if you can do it in a way that people will understand just what process we go through to ensure that the well is sound. So that they don't, that people understand about the drilling process, the cementing process, what exactly is involved in a
That's we could spend a whole semester talking about that. Okay, I'm going to talk a little bit, tie in a couple of things that some of the other speakers talked about. One of them was really we're talking about safety and avoidance of problems with spillage at the surface, right? They alluded to it. They talked about the fluids that not only do they have to come on the location to go into the well, but fluids come up and out of the borehole onto that location that need to be dealt with. I think if you look at the shale wells that are being developed in Ohio and Pennsylvania and anywhere in the world, you'll see first thing right away is they don't look anything like the conventional wells that have been drilled in the past. Wells that I've drilled in the past, we try to be pretty tactical about drilling a Clinton well. We only want to be there for 8 or 9 or 10 days. I mean, we don't like making noise and keeping the kids up at night and scaring the birds off and leaving mud on the road for the trustees to call us and yell at us about leaving mud on the road. We don't want any of that, right? So we try to be very quick in and get the well in, get it equipped, and get it hooked up and online and move out. And those are vertical conventional wells, which are really a totally different scale than the shale wells. So when you go look around and see all the land disturbance that goes on when they build a pad for drilling a shale well, the principal reason for designing that structurally and aerially is for safety and for containment and management of what's going to happen on that well site. Because like they said, it is scale-wise a significantly different kind of operation than the wells that we're used to seeing and drilling in Ohio. So I guess the example there is when a truck driver has been working for 2 months in a new job in Ohio, when a truck driver pulls onto a Chesapeake location, I'm just using them as an example because they have the most wells right now. They pull onto it doesn't matter where the location is in the state, that truck driver knows where he's supposed to go because those locations are designed identical. Right? So that's a safety issue. This truck bringing this diesel fuel for the motors or this truck coming in to pick up water off the location, they know exactly where to go on that pad. So they're not running into a piece of equipment they shouldn't run into. They're not trying to drive around the location to figure out where they're supposed to go. They come on and they're all the same, so they know where they're supposed to go. So I think when you drive by these locations, you see how big they are, and they're pretty impressive, and they look like an industrial park district. But the reason it's that way is to assist them in managing what's happening on that location. So that's quite a bit different from I've never myself personally drilled a Utica shale well. This is all new in the last few years. And most today, you look at the list of the companies that are drilling these shale wells, they're major oil companies. They're not our traditional oil and gas producers in the state of Ohio, but today own and operate 65,000 wells in the state. Produce just those wells alone produce about $1 billion worth of oil and natural gas that mostly stays within the state of Ohio. Those dollars and that activity and those jobs. So this new shale development is definitely something new. But the way they drill those wells, the way functionally how you drill that surface well through the aquifer and into bedrock is very similar to the way we've been doing it for a long time. There's multiple layers of steel and cement. I have a prop that I often bring when I talk to groups. It is two props actually. One is a piece of PVC pipe that is your typical water well, and then I've got a circle that I've got drafted out that shows the initial surface hole, which sometimes can be, 17, 18, 20 inches and bigger. That is uses a kind of a telescoping. I had my slides. I could show you pictures. It's a kind of a telescoping method of steel and cement that creates multiple layers between the production fluids that are interacting with the subsurface and so that they're not